Hello. Good evening to all of you.
Good evening, sir.
Good evening, sir.
Good evening. Am I audible?
Yes, sir.
Okay. Okay, let me start with attendance. Is my screen visible?
Yes, sir.
Please answer your attendance. Aditya Kumar.
Hello.
Yeah, Aditya Kumar. Anand.
Present, sir.
Ananta Kumar.
Present, sir.
Arnachalam.
Present, sir.
Hasan.
Present, sir.
Hemant.
Present, sir.
Jagan.
Yes, sir.
Kesav Prasad.
Yes, sir.
Lakshmi Narayanan.
Present, sir.
Prabhakaran.
Present, sir.
Prem Vinayak.
Present, sir.
Rahul.
Present, sir.
Rajan Kumar.
Present, sir.
Amit Kumar.
Present, sir.
Satish Kumar.
Present, sir.
Titus.
Present, sir.
Wallish.
Yes, sir.
Vigneshwaran.
Present, sir.
Vijayaraj. Vikas.
Present, sir.
Vivekanand.
Present, sir.
Yadav.
Present, sir.
Yuvraj.
Present, sir.
Okay, there are two absentees, Vijayaraj, Aditya Kumar.
Sir, Sir Aditya here.
Okay, I think you didn't answer. Okay,
Yes, sir. I just reached the classroom, sir.
okay. Vijayaraj is absent, right?
Yes, sir.
I'm just confirming. Okay, there is one absentee, Vijayaraj, today. Okay, so before I start the class, Aditya Kumar has answered the attendance, but he has left the meeting. I don't know.
No, sir. Here, sir, I am here in the classroom. Actually, I was trying to join through the phone to answer the attendance when I was on the way. So I just reached here in the meeting room, so I disconnected.
Fine. Okay. So here it shows that you have left the meeting. That's why I asked. Anand has raised the hand. Okay, go ahead, Anand. What is your question?
No, sir. He is raising hand for the attendance, sir.
Okay. Okay, so I have corrected your assignment as well as your quiz 1 answer scripts. Quiz 1 answer scripts you can collect whenever you are coming. I think you are coming for your other course exam, right? So when you come, you can collect the answer scripts from me. I have informed you the marks. Okay. So assignment 1 I have corrected and I have shared the link. You can download your assignment. So in the assignment corrections, if you notice any error, let me know so that I will look into it. Similarly, answer scripts, when you come and take the answer scripts from me, go through it. If there are any error in the corrections, let me know. Okay, so about the performance, it is not up to the mark. Assignment, there is no issue, but quiz one definitely you have to improve. First time I'm seeing your performance is definitely not up to the mark compared to the other batches. So I'm trying to understand. See, there are no full marks, 30 out of 30. The highest mark itself is 23 out of 30. Rahul scored highest mark. 23 is the highest. But it is not up to the mark, and the average is 15.9 out of 30. That is the class average. Why I am announcing class average in a relative grading system? Class average is important. So you need to check whether you are above the class average or below the class average. And so on the whole, it is not a good performance. You know very well. If you have any specific reasons, let me know. So my role here is I'm not happy with the performance. I can help you in whatever way I can. I can spend additional time, and those, especially those who have scored very low marks, you need to discuss with me and then see how you can improve. Otherwise, it will be a problem, right? So what I am surprised is this is the first time I'm seeing such a performance in my course. Generally, it won't happen. And that's why I'm trying to understand. So one thing while taking attendance, I noticed that whenever you unmute the mic, I see a lot of disturbance, background noise coming. I'm not sure whether you are sitting in a designated classroom and listening the class. If that is not there, then the very purpose of taking class will be of no use for you. So you need to be it should be like an ideal classroom, although it's a virtual online. You need to have a required ambience to listen to what I am teaching in the class. If there is no ambience, I mean the required ambience, okay, that is your responsibility and your industry responsibility, right? I cannot do micromanagement, I cannot check. But the way you answer the attendance, during few seconds, I could notice that there are a lot of noise and disturbances behind you. I'm not sure if that is the case, how you are able to listen and follow up with the class. Then it will become definitely a problem for you, right? You won't catch up with what I am talking, right? Simply your physical presence is not going to help. I know it is the end of the day, you are listening to the lecture after your industry work, but you have no choice. That is how the courses will run for you, right? In the online course, because that is how this particular course will go on, right? LTech Automotive. This is well known, and the only my concern is unless otherwise you have a required ambience, right? A classroom ambience. It will be of no use to you. I can tell you have to have focus. This 50 minutes, you need to completely focus what I am teaching, right? That focus will be there only if the ambience, required ambience is maintained. Then only you can catch up with what I am telling. You need to closely watch. You need to take lecture notes. I don't think anything outside what I am talking is asked in the exam. Okay, so it's autonomous institute. I know you cannot spend additional time, right? More time in going through all the references. That is also well taken, but you should have the responsibility of maintaining the required ambience, attending the class regularly, taking lecture notes regularly. If this is not done, then you are going to have the problem with the course. So I'm trying to understand from you whether everything is fine at your end, whether you are able to follow with the course, whether the required ambience is maintained. Maybe Mr. Arnachalam, you can tell about what is going on in Mahendra. The other three are from Pune. So here in Mahendra, you have a designated classroom and yes, you are able to listen without any disturbance, right?
Yes, sir. We are specifically Mahindra has given a dedicated room for us. Some people are traveling that time only. You will get some noise and all. So most of the people are sitting inside the room only, sir.
Okay, so sitting inside the room and there is no noise or any other disturbance for you during the class hours?
No, nothing, sir. Only people who are traveling on business trip only will have some disturbance, sir. The rest of the people will sit in the same specified room and we are watching your teaching, sir.
Okay, and are you taking the class notes regularly? All of you are taking lecture notes?
We are taking the lecture notes regularly.
That is important. Why I am specifically saying this is until you write, it won't go to your mind. If you listen, see, your memory is volatile, especially after a certain age, right? We always have a volatile memory and that will increase with age. So until otherwise you write, nothing will get recorded in your mind. Just listening here for 50 minutes also won't help. You have to write and record. there are two advantages. One, if you write, it will go to your mind and get recorded. Second one, it will become a good reference for you in future also. So you should have the habit of recording the lecture material or lecture notes. Otherwise, it won't serve the purpose. Okay, and this will also be a good reference for preparing your exams. Before
Sir, we are doing we are doing like that only based on your notes you are shared to us now, sir. Based on that, we have made all the notes. Definitely we are very much lagging beyond the expectations, sir. We agree on that, sir.
Yeah, the only thing is, it is although it is challenging, time management is challenging because you have several things to do, but there is no other way until you spend time, right? So everything demand time. For academics also, you need to spend time. Whatever time you need to spend, you have to. We cannot compromise. If you compromise that, then it will reflect in poor performance.
Sure, sir. Next time, definitely we will improve our things.
Okay. So is there anything specific from any of you? Since you are representing, I'm talking to you. Others also, if there is any specific things or difficulty in following up or any other difficulty, you should let me know so that I'll see how it can be worked out and how I can help you to improve your performance. Okay, that's the idea.
Only thing from your side, you are going on the right track, sir. But we are just try to match up with you, sir. That is what.
Okay. So basically, you mean to say that due to other commitments, this time you didn't spend more time for the exam.
Yeah, this time we spend more time, but it is not enough, sir. That is what I'm saying.
Sir, and one more thing, sir. Actually, the problems, I mean, for my side at least, the problems was aware, but time was the main constraint, sir. That was totally my mistake, sir, because I got dragged away too much on the theory part too. So by the time I had finished the question number 3, I had only 20 minutes left. So I took the number 6 question and then coming back to 4 and 5, ideally I didn't attempt only, sir. So the your side, the notes and whatever you have given is perfect, sir. It's just that our proper planning was missing, sir. I think for most of the people, they said that the timing could not be matched up, sir. That was the main reason, sir.
Okay, so regarding the timing, I have done, see, when I release the question paper, before that I have done a lot of homework to see whether it is answerable in 50 minutes. Until otherwise, I am convinced I won't. This time, in fact, actually, I have removed one question. I already told you. And earlier, it was even higher than that. Okay, so the number of questions I have checked, how much time each question will take, I have checked. I have confirmed that it can be well within 50 minutes. Okay. So that check I have done. Only thing, since you are new to the system, you should not be writing descriptive answers. I have seen some of you written in pages, two pages for the first question. Okay, so that is not at all required. What is asked up to that point, you have to answer. Few bullet points, enough. I am just checking whether you understood the concept or not before giving full marks. So, okay, so don't expect that descriptive answers will fetch more marks and brief answers will, the marks will be reduced. No, never. It is just, I will just check whether you understood the concepts or not. Very brief, 1 or 2 lines are enough for all the theory questions. For the subsequent exam, you just take a note that the purpose of the theory question is when I evaluate, I just check whether you understood the concepts or not. Okay, detailed descriptive answers are not at all required.
Understood, sir.
One small request, sir.
Yeah, so there is a question. Yes, go ahead.
Sir, during this exam, if possible, just a small request only, sir. If possible, if you give some 5 to 10 minutes just to go through the question paper alone, it would be helpful, sir. At that time, nobody should write the answer. Just to go through read the question alone. Just a request only, sir.
So reading the question, see, the thing is, okay, so if you want me to give additional time, I can give. But again, what the important point you should note is, the questions I am setting is for 50 minutes. Okay. And any additional time given is compromising the quality of the process. Did you understand? Especially in a relative grading system. This is how all the exams, IIT, JEE, you know how it goes. GATE, how it goes, you know. Any relative grading exams, the time is more important. Even 1 minute here and there, they won't get compromised. Okay, because that 1 minute or within the designated time, how quickly you are responding and answering is what people will check in a relative grading system. Okay, it is not absolute marks. In absolute marks, it's totally different. In a relative grading, maintaining precise timing for the exam process is very, very important. That is our responsibility. So if you want additional time, I can give. That is absolutely fine. But I cannot make it an official announcement that it is 15 minutes, but I will officially conduct the exam for 1 hour. No, I am not permitted to do that. You understand? Then I am not doing my job correctly. In a relative grading system, timing needs to be maintained precisely by the person who is conducting the exam. I cannot officially say that it will be printed as 50 minutes, but I will give 1 hour. No, then it is absolutely wrong. But based on the question paper, if all of you request for 5 minutes additional time after the questions are given, I can give. Okay, that I will be considering that on case by case basis. But I cannot make it as an official that for 50 minutes exam I will give 1 hour time. No, it is absolutely wrong. That's what I am saying. Even few minutes I should not increase officially. But next time, if you feel that for quiz 2, additional 5 minutes are required, all of you let me know when the exam is going on. I will consider that.
No, sir. Thank you, sir.
Only one request, sir. Basically, while we are giving the exam online, so it would be better that if you get the print of the question paper, because reading questions on paper and on a screen makes a difference, lot of difference in that way. And probably what Jagan was telling that since theory part was probably we could not timed our exam in a efficient manner, I would say. The questions that
Okay, I could not hear you. Hello?
No, his voice is stuck, sir.
I could not hear you, but to answer his question again, Roshan, in that case, I am compromising the integrity of the exam.
No, sir.
I'm allow you to take a printout during the exam time because I send the question paper precisely just before the exam, few minutes. Right? If I allow you to take printout, then it goes out of control. Right? You are using a printer, you are taking copies. Okay, during the exam time, it's absolutely we cannot do that. It is like you are sitting in an exam hall and taking an exam. Online exam is conducted to avoid your travel time, right, from Pune to here. Right, this consideration is given to you on a case by case basis. But strictly speaking, you three also should come and take that was decided right as a decision to conduct the exam. But during online exam, we are not supposed to allow you to use any electronic gadgets, including printers. It is against the integrity of the exam process. You already asked about it, but I denied because we need to conduct the exam strictly, even online exam. And as per the institute mandate, no electronic gadgets are allowed once the question paper is sent to you.
Noted, sir.
Really nothing. So only one device you should use to view the question. There is a difficulty, I understand, but the difficulty is because you requested for online exam. Since you cannot take the in-person exam, we have agreed for 3 of you.
Sir, we'll follow the instructions, sir. No problem. No problem.
This, whatever I am following is IITM mandated rules for conducting exam. I need to strictly follow. Relaxing time or allowing electronic gadgets, all these are against the exam process.
Noted. Thank you, sir.
Right, I need to ensure that I am doing my duty correctly. There will be a little bit of flexibility I can do case by case basis. Like second quiz, if you feel that you need 5 more minutes time, during that time you can request for it. I can collect the answers through 5 minutes late, but I cannot give question paper early like Sabhi just requested. If the exam start time is say 10 o'clock, I should give at 10 o'clock. I should not give at 9:50 or 9:55. That is not permitted for me. Okay. But during the exam, you can request that you need 5 more minutes. If majority of you feel that way, then for all of us, I can consider 5 minutes extended time.
Understood, sir. Yes.
Okay, sir. Okay, sir.
Sir, one request, sir.
Yes.
For this one, can we get a model answer sheet?
Yes, yes. So what I will do,
so that we can have
yes.
a basic idea how to answer the theory questions and numericals as well.
Yes. So what I will do, I'll prepare an answer key both for assignment as well as for quiz 1 questions. I will send it to you. You can also have a look at it. Especially you can check the answers, the numbers, okay, for the problems. For the theory questions, you can check how you should answer to shorten the time. Maybe if it helps you, I will send the answer key, prepare the answer key and send it to you, both for assignment as well as for the quiz 1.
Thank you,
okay,
sir.
so I hope I have answered your queries and there are no more queries. If there are any other questions, you can always write to me. You feel free to reach out to me over phone or email. I can get back to you. See, the purpose here is not to criticize or anything. I want to help you so that you can do a good performance.
Sure, sir.
Sir, our batch performance
Thank
is
you,
much
sir.
inferior to the previous batches, or what? Is that so?
What is it?
Like our batch overall performance is very inferior to the previous compared to previous batches.
No, again, see, it's not good to compare one batch with other batch.
No, just out of curiosity, I'm asking, sir. Not from the.
Yeah, compared to the other batch, the class average is less this time for quiz 1.
Okay, sir.
And you need to work on it definitely. Again, the purpose here is not to criticize you. Take it in a positive sense and do more hard work, right? It's only your hard work that will finally return. Whatever you are getting as a marks is reflects how much of hard work you have done, right? Nothing more than that. I am just a facilitator here. It's all your work. You get the credit for the work you have done. Okay.
Thank you, sir. Thank you so much.
Thank you, sir. Thank you, sir.
Thank you, sir.
Yeah, thank you. So I will get back to where I stopped in the previous class. So we are now discussing CI engine combustion in this chapter 3. I've started with the overview of CI engine combustion. Then I discuss about the different stages of CI engine combustion. As discussed, the CI engine happens in 4 distinct stages. CI engine combustion happens in 4 distinct stages, starting with ignition delay time. Then there is a premix phase of combustion, followed by diffusion phase combustion, finally afterburn or late combustion phase. So it happens in 4 distinct stages, unlike in SI engine wherein we have 3 stages of combustion. And the overall combustion even here in a CI engine is dominated by the mixing process, fuel air mixing process, because we have very limited time for mixing fuel and air since the fuel is introduced during the compression stroke. Near the end of compression stroke, we introduce fuel into the cylinder. Okay, and due to the very limited time that we have for fuel air mixing, we end up in having a heterogeneous fuel air combustion. And the overall combustion event or the rate of heat release is based on how quickly fuel and air mix and burn. Okay, so it's a mixing dominated process, CI engine combustion process, as compared to SI engine, wherein fuel and air are well mixed. We have a homogeneous mixture, and the way the heat release happens, the rate of heat release is governed primarily by the rate at which the flame moves across the combustion chamber. So it's a flame propagation based combustion phenomenon in SI engine, and fuel air mixing based combustion phenomenon in CI engine. And it happens in 4 stages as we discussed. After characterizing the combustion in terms of different stages, we identified factors. This is where I stopped in the previous class. We identified various factors that influence CI engine combustion. And these factors are fuel based, engine design based, as well as engine operating conditions base. So there are different factors that affect stages of combustion. Among the 4 stages, whatever I said, the first stage, ignition delay time, is what is very important in a CI engine. So based on the duration of the ignition delay time, the subsequent stages of CI engine combustion like premix, diffusion and afterburn. Afterburn is the last stage, generally around 10 to 15% of the fuel only burn. The second and third stage of combustion is dependent on the duration of delay. If the delay time is so long, then you will have more intense premix, very little diffusion. If the delay time is shorter, you will have a less premix combustion and more diffusion combustion. So overall combustion event is the duration is based on the duration of the delay time. That's why we spend time to understand the various factors that affect the ignition delay time, which is the first stage of the CI engine combustion. So here we have discussed about these are the factors. Okay, these are the factors that influence CI engine combustion, starting with the fuel-based factor, CTN number. It's one of the most important variable. That's why we need to have fuel with the minimum CTN number to run the diesel engine. Okay, minimum is around 40, as we have discussed in chapter 1. Below 40, you will have a problem. The engine may not even start. Okay, so the delay time affects startability as well as knocking. Knocking is based on very high rate of pressure rise. If the delay time is too long, if there is a ignition and delay time is too long, you may have knocking kind of combustion, because too much of fuel injected during the delay time will burn instantaneously and produce knocking kind of combustion. So you need to ensure that you have fuel with a required ignition quality defined by CTN number to avoid a long delay time, which may eventually lead to knocking kind of combustion. Injection pressure effect is also there because it affects the rate of vaporization and mixing, which is a physical delay time. Higher injection pressure helps in reducing the delay time. Higher the injection pressure, the delay time will be shorter because at the higher injection pressure, the drop size is reduced. Atomization is better. This is what we discussed. Smaller drop size will increase the rate of vaporization because vaporization is dependent on the size of the drop. Smaller the drop, the surface to volume ratio will be very high. It will absorb heat, latent heat from air quickly and vaporize quickly. So physical delay time will be reduced and overall ignition delay will be reduced if injection pressure is increased. That is the effect of injection pressure on the delay time. Then we have compression ratio. So increasing compression ratio will increase in cylinder pressure and temperature. That will definitely shorten the ignition delay time. Higher pressure and temperature in the cylinder at the time of fuel injection will help in reducing the overall ignition delay time. Engine speed effect. There are 2 effects. One in absolute time scale, which is going to come down because at higher engine speed, the time available for heat loss is reduced. So time available for heat loss is reduced. More heat will be reduced. More heat will be retained in the engine cylinder. That will reduce the ignition delay time in absolute time scale. But in terms of angle, it will be high because at higher engine speed, more angle will be covered in a given time t. Okay, the crankshaft angle covered is also a function of time. Is also a function of engine speed. At higher engine speed, since the engine spins at higher RPM, the angle covered will be more. So in terms of crank angle at higher engine speed, the delay time seems to be higher, but actually in absolute time scale, the delay time is less with engine speed because of less time available for heat loss. More heat will be retained and overall delay time will get reduced in absolute time. Engine load. When you increase engine load, you are in a diesel engine, you are increasing engine load by increasing fuel mass. Air mass is constant, fuel mass is increased to increase engine load. At higher engine load, since you are burning more fuel, the in-cylinder pressure and temperature are high. The higher in-cylinder pressure and temperature will reduce the overall delay time. That is what is happening. That is the effect of engine load. At low load, the opposite effect will be there, as we have discussed. So if you plot ignition delay time versus load, you will get a trend like this, decreasing trend like this. It's not a linear, it's somewhat non-linear trend, as you could observe from the trend line. Okay, but the overall effect is there will be drop in ignition delay with the increase in engine load, because as the load increases, pressure and temperature in the cylinder is high. Since we are burning more fuel and more thermal energy is released, pressure and temperature will be high. That's why the delay time, ignition delay time will get reduced at high load. Opposite effect will be there at low load. You will have a long ignition delay time at low load because the pressure and temperature are relatively low. Injection timing is another important variable. It's an operating variable. When you are running the engine, you can vary the injection timing. In fact, you need to optimize the injection timing based on operating condition. So when we talk about injection timing, there are two options here. One is either it can be advanced or it can be delayed or retarded. We use the word retard or delay, both are same. So it can be advanced injection timing or it can be a delayed or retarded injection timing. So in which case ignition delay time will be shorter. Suppose if we intend to reduce the ignition delay time, whether you need to advance the timing or delay the timing.
Sir, with retarded injection, it will be lower ignition delays.
Okay, so I am just showing it with respect to piston compression TDC portion. This is what I mean by advanced injection timing. This is retarded injection timing. So when I inject fuel here, it means the piston is here at the time of fuel injection. That is what I mean by advanced injection timing. I'm spraying. I start to spray the fuel when the piston is here. This is case 1, advanced injection timing. This is case 2, retarded injection timing. I start to spray fuel when the piston is occupying this particular position. Okay, it is very close to TDC. That's why it is called delay timing or retarded timing. In this case, the piston is away from compression TDC. That's why you use the word advanced timing. So as you rightly said, in case 2, suppose if we consider the in-cylinder conditions as P1, T1 for case 1, retarded timing P2, T2, okay, case 2. So in-cylinder pressure and temperature conditions are different based on the fuel injection timing. Whether P1, T1 will be higher or P2, T2 will be higher?
P2, T2 will be higher, sir.
P2, T2 will be higher compared to P1, T1. So basically you are allowing more compression. So the time at which you spray the fuel is going to decide the in-cylinder pressure and temperature condition. With the retarded injection timing, you are allowing more compression. Since you allowed more compression, the pressure and temperature inside the cylinder is going to be high. That is what you are observing. When the pressure and temperature in the cylinder is high at the time of fuel spray, the fuel is going to take lesser time for vaporization mixing. And also, since the temperatures are high, the chemical delay time will also be less. So, you know, overall ignition delay time is dependent on physical and chemical delay. Both will be shortened when you retard the injection because the pressure and temperature conditions are high at the time of fuel spray. This is the effect of fuel injection timing on the delay time. So, with retarded injection timing, you have a shorter ignition delay time. Then we have intake temperature. So the intake temperature is based on ambient condition. You know, ambient temperature also varies with respect to season. Even within a day, it is going to change. Sometimes you also use some heating system. If there is a heating system in the engine intake manifold, then accordingly the intake temperature is going to be different. So what will be the effect of increasing intake temperature on the delay time? Suppose if the
it should reduce actually.
Yes, so it's a straightforward thing. So when temperatures are high during the intake, the overall delay time is going to drop because you know temperature effect on the delay time is higher the temperature, shorter will be the delay. Both physical delay and chemical delay will be shortened. But generally, we don't prefer to increase intake temperature. What will be the other effect of intake temperature?
Reducing volumetric efficiency.
Exactly. So when you are increasing intake temperature, volumetric efficiency will drop because higher temperature will result in less mass. When temperature is increased, the mass that fills into the engine cylinder is going to be reduced because density effect. So in a given volume, displacement volume is available volume. So within the available time with the given volume, you have to fill more mass. The mass that you fill is dependent on the density. Higher the temperature, shorter will be, higher the temperature, you will have an effect of lower density. Okay, so mass that goes into the cylinder is reduced. That's why volumetric efficiency drops. So generally we avoid keeping a high intake temperature because that will have an effect on mass of the air that goes into the cylinder that will directly affect the power output. Less mass is, when less mass is filled, you will have a lower power output. Intake pressure. So suppose if you have a intake pressure, again, it depends on ambient condition. Ambient pressure doesn't vary much, but if you use a supercharger or a turbocharger, then accordingly, the pressure will be increased. If you use a super or turbocharger, pressure will be high. If intake pressure is high, what will be its effect on the ignition delay time?
It will reduce.
Yeah, higher pressure will reduce delay time because higher the pressure, you are actually increasing the mass that goes into the cylinder. So you are burning more. When you burn more, you are going to increase pressure and temperature in the cylinder. Overall effect will be a shortened ignition delay. So you can say that supercharged or turbocharged engine will have a shorter ignition delay compared to the naturally aspirated engines. Okay, so these are the effect of these important variables on the ignition delay time. Based on variations in ignition delay time, you are going to have a variation in the premix phase combustion and diffusion phase combustion, as I have said earlier. So one of the important consideration here is we need to ensure that the delay time is not too long. Otherwise, you will have a problem of engine startability as well as you may have a knocking kind of combustion. Okay, so when we handle these factors, we need to ensure that we have a minimal ignition delay time so that you can avoid these problems of startability or knocking combustion. Is it clear? Okay, so the next topic is about knocking or abnormal combustion. So we are here, we are now going to discuss about abnormal combustion in CI engine. So in a CI engine, as we have analyzed the mechanism of knocking combustion in SI engine, here also we are going to analyze the mechanism behind knocking combustion in CI engine. Okay, so we can do that by analyzing the pressure profile. Pressure versus crank angle profile is called pressure profile. This is the pressure profile for a normal combustion. Okay, normal combustion, TDC, compression TDC is a reference point. You have a smooth pressure profile as you could see here. This is how normal CI engine combustion look like. In case of knocking or abnormal combustion, you could see pulsations in the pressure profile. Okay, and then the for a particular period, you see here, this is a crank angle instant at which there is a pulsation. So this pulsation is an indication of knocking combustion in a CI engine. Pressure pulsations is an indication of knocking combustion. So for a particular period of time, you could see that there is a pulsation. What is the mechanism behind this knocking combustion in CI engine? That's what we are going to look at here. So as we have just now discussed, it is very important to control the ignition delay time. The knocking combustion in CI engine happens primarily due to a long ignition delay time. If ignition delay time is longer, okay, if the delay time is longer, so as we have discussed the different stages of combustion, the first stage is what is ignition delay time. If ignition delay time is longer, the subsequent premix phase combustion will be more intense. Okay, more intense. And this premix phase combustion is called the uncontrolled combustion phase because when the ignition delay is longer, you are spraying more fuel during this ignition delay period. If more fuel is sprayed during the delay period, okay, you will have a higher proportion of fuel and air pre-mixed. Fuel and air pre-mixed. This pre-mixed fuel and air is what is combusting in the second stage, which is an uncontrolled stage of combustion. So when you have more amount of fuel and air prepared during the ignition delay time, in the premix phase combustion, that prepared fuel and air, when I say prepared, I am talking about pre-ignitable range. Remember that combustion can only happen when you have a proper combination of these two. So when the delay is more, I'm injecting more fuel during the delay time. That injected fuel will get prepared with the air, because inside the cylinder you have air at a higher pressure and temperature. Fuel and air will be prepared within ignitable range. I'm talking about an increase in ignitable range of fuel. You have more ignitable range of fuel inside the cylinder, and if you have a proper ignition temperature, this Phi ignition and T ignition will result in very high thermal energy release during the second stage, which is a premix stage combustion. So when the delay time is more, you have an accumulation of larger mass of fuel or larger quantity of fuel inside the engine cylinder. Okay, this larger mass of fuel prepared with air will undergo instantaneous ignition after the end of the delay time. After the end of delay time, there is a start of combustion. The time of start of combustion, you have a large proportion of Phi ignitable range. Okay, this mixture is going to burn instantaneously, and this instantaneous burning of larger mass of fuel will result in very high pressure locally. You know, pressure is a wave phenomenon. Pressure will try to equilibrate as quickly as possible. So what is happening, because of a longer delay time, you have a very high proportion of fuel prepared in the ignitable range, and that mixture is igniting. After ignition, that mixture is releasing large thermal energy, okay, for a moment. So you have a very high local pressure compared to the average pressure. So inside the cylinder, there is an average pressure, but because of long delay and more intense premix combustion, there is a significant rise in local pressure. So you have an extreme pressure difference, P average and P local. There is an extreme variation in these two. This extreme pressure difference is what is causing knocking combustion. So there will be violent gas vibrations, and these waves, extreme pressure difference, result in pressure waves of larger amplitude that will go and hit the cylinder wall, okay, and create this audible sound. That's why it's called knock, as I already discussed in SI engine. You have extreme pressure difference, and the wave generated due to extreme pressure difference will propagate and hit the cylinder wall, make it to vibrate. It also produces an audible sound. That's why it is called knocking. I already said that the decibel level that you generate during knocking is very high. It is audible to the human ear. During normal combustion, you won't hear anything. Okay, it's not audible. But during knocking, the waves of larger amplitude will hit the cylinder wall, increase the audibility. Combustion noise levels are high. That is one immediate effect. Second effect, the vibration. Since the waves are hitting the cylinder wall, it will set the wall to vibrate, and this vibration will also be transmitted to the crankshaft. Crankshaft will also start to vibrate. Okay, so there will be increase in noise, and there will be increase in vibration. So for a momentary period of time, if knock happens, it's not going to create a larger damage, right? But there are other effects. But prolonged knocking for a longer period of time is eventually will damage the engine components. Primarily piston, the components that are exposed to high pressure gases will get damaged, like piston and cylinder head, valves, all these components will get damaged, okay? It's having an undesirable effect on the engine, right? On a long term, it affects the durability. So the primary reason for this is very high pressurized rate that is generated locally due to high pressure. Due to high thermal energy released locally, you have a high pressurized rate. So there is a criteria that we use to classify whether it is knock or abnormal or normal combustion. The pressurized rate, dP by d theta max value, that's a max value. It should not go beyond 8 bar per degree crank angle. What I mean by dP by d theta is this value. The slope, okay, here you have P, you have theta. The first derivative is what dP by d theta. So this is dP, this is theta, okay. The slope of this is dP by d theta. It should not be too high. If it is too high, it is approaching the vertical line, right? So this is further steeper. If it is the the limits are, this is horizontal and this is vertical line. When I say slope is high, it's approaching the vertical line. Okay. So when it is beyond 8 bar per degree crank angle, you classify that as a knocking combustion event in a CA engine. That is how we classify knock, and of course it is audible to the human ear. The decibel levels are high. We will also look at the dP by d theta value by looking at the pressure profile. When it is higher, above 8 or 10 bar at the most, we will classify it as a knocking kind of combustion. This high pressurized rate is primarily due to large volume of thermal energy released at the time of knocking. Okay, and this is primarily due to very long ignition delay. So the effect of the knock that happens in the engine is primarily due to the delay time, ignition delay time. When the delay is too long, you end up in having knocking combustion. So what should you do to avoid this?
The fuel with better certain number.
Yeah, so the most important parameter, as we have just now discussed, cetane number. That's why you are not allowed to run a diesel engine with cetane number less than 40. Okay, in order to avoid the long ignition delay time. So if you have cetane number less than 40, you can expect a long delay time and a knocking combustion in a CA engine. So fuel ignition quality will play a significant role in avoiding knocking combustion. Another effect is compression ratio and other engine operating variable, as we have discussed. So you need to keep a check on all these variables. It's a combination of all the parameters that affect. Please note that when we discuss about parametric effect, we are considering the effect of only that parameter, keeping other parameters as constant. But in an actual engine, all this parameter will play a combined role. It's a cumulative effect. So you need to ensure that fuel has a required ignition quality, engine has a required compression ratio, and other operating variables like fuel injection timing are also properly controlled so as to avoid the knocking kind of combustion in CA engine. Okay, so that is how it happens. This is the mechanism behind knocking in CA engine. The primary factor is the delay time. Keep a check on the ignition delay time. Ensure that it is not too long. Now, having understood the knocking phenomenon SI and CA engine, now let us look at what are the differences in the phenomena, knocking phenomena in this two engine. So what difference you could find between knocking in SI and CA engine? Have you identified any difference having understood the mechanism of this process in this two engine?
Before TDC and after TDC actually.
Yeah, so I have just presented the profile, pressure profile during knocking in SI engine and CA engine here. This is CA engine, this is SI engine. Just look at the profile. You could see that the knock is happening here in this period of time, crank angle time, whereas knock is happening here in this period of time in a CA engine. You could see that knocking is happening at the time of start of combustion in a CA engine, primarily due to long delay. Whereas in SI engine, what is the mechanism for knocking in SI engine?
It's basically the end gas
auto ignition, right? In-gas auto ignition. You should always remember the mechanism to compare knocking in this two engine. In SI engine, it is in-gas auto ignition, meaning the flame takes, if the flame takes more time to reach the end gas, by the time the end gas will reach self-ignition temperature and knock happens due to that. Okay, so it is happening during the end of combustion process in a SI engine. Whereas in a CA engine, it happens due to long ignition delay, which is happening at the start of combustion process. So knock happens at the start of combustion process before the occurrence of Pmax. So this is Pmax occurrence. Knock happens at the time of start of combustion in a CA engine before the occurrence of Pmax in the compression ignition engine. Whereas in SI engine, the mechanism is due to self-ignition of our end gas, and that will happen during the end of combustion. So you could see that knock happens after the occurrence of Pmax in SI engine. So knocking happens near the end of combustion after the occurrence of Pmax. So this is maximum pressure. After the occurrence of maximum pressure, knocking is happening in SI engine. Whereas in a CA engine, knocking happens before the combustion gets started. So it happens before the occurrence of Pmax. This is one of the important difference in the knocking process in SI and CA engine. The other important difference is in SI engine, you have a homogeneous mixture, fuel air mixture. CA engine, always have heterogeneous mixture. So intensity of the knock is high in a SI engine compared to CI engine because SI engines have a homogeneous mixture and phi value, it is close to stoichiometry or slightly rich. Slightly rich is going to create a very high temperature in the cylinder, and that's the reason why SI engine operating temperatures are high. So the knock intensity in a SI engine is generally high because of the operating phi and a homogeneous mixture. In CI engine, operating phi is always lean. So this is close to 1 or 1.1. So this results in very high temperature. This overall lean mixture results in lower temperature. Also, mixture is heterogeneous since we give less time for mixing. So intensity of knock is very high in SI engine compared to CI engine. And we have already discussed that in SI engine, knocking can also lead to pre-ignition. What is pre-ignition?
So basically, ignition which happens before the approach of flame front actually.
Spark discharge.
Yeah.
Before you discharge electric spark, if there is an ignition, then it is called pre-ignition. Why it happens? It happens because of the hard surfaces in the engine cylinder. So if knocking happens, the surfaces inside the cylinder, for example, spark plug, valves, the surface of valve, surface of spark plug may reach very high value, surface temperature. And this temperature is enough for creating ignition of fuel air mixture that is injected into the engine cylinder. So in knock, there is a subsequent pre-ignition. Whenever there is a knock, you can expect there will be pre-ignition before discharging spark in SI engine. In CI engine, there is no pre-ignition. CI engine, there is no pre-ignition like in SI. Can you point out any reason why it is so?
Lower ignition delay and
so even after there is a knock, the pre-ignition event is generally avoided in CI engine, unlike SI engine. There are two reasons. One, just now I said operating temperatures are less, so the surfaces won't reach very high temperature. And what you are inducting into the engine cylinder is only air. Unlike in SI engine, where you induct air fuel mixture, here you during the intake stroke you are taking in only air. Okay, even if the surfaces are high temperature, you don't have an ignitable mixture. Until otherwise you have an ignitable mixture, you are not going to get pre-ignition. Did you get what I am saying?
Yes, sir.
So that's why pre-ignition is avoided in CI engine since operating temperatures are less and you inject only air into the cylinder during intake. You don't have sufficient pre-ignition to undergo pre-ignition. Okay, whereas in SI engine, you have a pre-mixed fuel air mixture that is well within the ignitable range. Operating temperatures are high. That's why if there is a knock, this surface temperature will result in pre-ignition. And the other important difference is, SI engines need high octane fuel primarily because they want better antenna quality. CA engines need high C10 fuel. Primarily, they want high ignition quality. And octane number and C10 number are inversely proportional, meaning antenna quality and ignition quality, you can say that they are inversely proportional. So fuel with a better octane number or a better characteristic for SI engine application cannot be a better fuel for CI engine application. The fuel that avoid knocking combustion in SI engine will result in high knock in CI engine. For example, if you use a high octane fuel in CI engine, what will happen?
It will knock, sir.
It will knock because high octane fuel is going to result in long ignition delay, as simple as that. When octane number is high, ignition delay is high, so you will have a knock in CI engine. Okay, so CI engine combustion itself is self-ignition based combustion. We want to have a fuel air mixture that undergoes self-ignition quickly, whereas in SI engine, we want to avoid that. The end gas should not self-ignite at any point of time. So we want the fuel air mixture to resist self-ignition in SI engine application, whereas the opposite is what we want to avoid knocking combustion in CI engine. We want the fuel to self-ignite quickly. Okay, a good fuel for SI engine application cannot be a good fuel for CI engine application. It's time up. I stop here. If you have any questions, you can ask.
Thank you, sir. Sir, one doubt.
Yes.
In this pre-ignition knocking in SI engine, will the P theta diagram will go for a change, or will it be remain the same, sir?
P theta diagram. So P theta diagram, pressure crank angle diagram is based on when the ignition is happening. Definitely the profile will be different if you have pre-ignition. Pre-ignition is a kind of untimed ignition or uncontrolled ignition. Okay. Suppose during the compression event, somewhere if the ignition gets started here, you can expect a high pressurized rate. So you want ignition to happen at a particular period of time, right? You control that using spark discharge in SI engine. You are controlling that using injection timing in CI engine. We want a well-controlled start of combustion. We do that through spark discharge in SI and fuel injection timing in CI. Pre-ignition is out of control. You are not controlling when the ignition is happening, right? So it can happen anywhere very early also during the compression stroke. So profile will be different because very early ignition during compression stroke will result in high dP by d theta. So basically, if there is a pre-ignition, then again knocking tendency will increase. Right? It is like a worst case scenario. Knocking leading to pre-ignition is a worst case scenario. It will definitely damage the engine.
Right. Thanks.
Okay. Okay, so I stop here. I will see you tomorrow at 6 o'clock. Thank you. Bye.
Thank you, sir.
Thank you, sir.
Yeah.
Thank you, sir.
Thank you.
Thank you, sir.